Software Engineering Radio, Episode 27, Service-Oriented Architecture, Part 1. Welcome to Software Engineering Radio. This is the first episode in our mini-series on service-oriented architectures. In this episode, myself, Markus, and
Eberhard
will be talking about the basics of service-oriented architectures, motivating the topic, and coming up with a relatively non-technical view on SOA. In subsequent episodes or subsequent parts of this SOA series, we'll get more and more technical and more specific.
And we will also talk about the historic origins of SOA.
Right. As you said, we should probably start by motivating where SOA comes from which other philosophies or paradigms it developed. And I think you've prepared a little case study from which we can start, right?
Yeah, it's an imaginary case study. So what we do is we have a company and we look at how the company developed its software environment and its IT infrastructure during the several different technologies. And the case that we are going to talk about is how they deal with the orders that come in, because this is something that every company does, and it also has interfaces to all of the other processes that are there in the company. So in the beginning, which is in our case about the 70s,
there was light.
Yeah, sort of. In the beginning there was the Word, I think, and
right.
anyway, so. In the 70s, the company started doing IT stuff, and in our case, as usual, with mainframes. And to get a historic comparison, in 1972, the German company SAP was founded. So this is where, in those times, it was mostly handwritten software that was used. So they developed a monolithic mainframe application with terminals and a batch-oriented system, so all the orders of the day are processed in one big batch. And this is sort of the first step of the IT system in the company. The next technology that evolved were PCs in the 80s because of things like spreadsheet applications. And shrink-wrapped office applications, and also terminal emulations were used on those PCs to get access to the mainframe, and also new servers showed up that were used by the several parts of the company to store their own files in. And this was in the 90s. The PCs were graphical user interfaces were added to the PCs in the 90s. And now the question arises whether this should be used for the applications of the company itself also, and not just for the shrink-wrap applications that they buy from some vendors.
So you're saying that the real applications of the enterprise were still server or mainframe based with terminal emulations, and the GUIs on the clients were only used for those ad hoc, Excel or Multiplan or whatever it was called, spreadsheet calculations.
VisiCalc and things like that, exactly. Yeah. And then graphical user interfaces came up with Excel, for example. And now the question is, can't we have something more nice for those individual applications as well?
And that's probably where client-server computing came up then.
And also, to a certain degree, object orientation, I think.
Okay.
So in my opinion, object orientation is somehow connected to graphical user interfaces to a certain extent, because it's quite nice and easy to do graphical user interfaces using object-oriented systems. And you can see this by that Smalltalk, for example, was closely linked to graphical user interfaces things like Microsoft Foundation classes. Also, if you look at the original design patterns, a lot of the things were about graphical user interfaces. The examples in this book were about graphical user interfaces, so it's somehow linked. It's not.
There was this framework where Erich Gamma worked on. I forget how it's called, but many of the examples in the Gov book are from that framework.
Exactly. So, so why using object orientation? Because of graphical user interfaces, as I said, and nowadays it's becoming more important that it's an integrated development model. So you have means to analyze the business for design and also for programming. And the big things that were promised were better maintainability, better reuse, and things like that.
And as we all know, this only materialized to some extent.
To a certain extent.
Yeah.
Exactly, yeah. And now if you look at the structure of the IT system that we have in this company, we have this monolithic mainframe application. And if you do some kind of graphical user interface thing for order processing, the problem is that the mainframe application is still there and you still have to deal with it. So what usually happens is that you actually do a rather thin application in some object-oriented language like C++, for example, and the real business logic is still on the mainframe. So this is what the company learned during this project. Yes, you can do a GUI with this object-oriented system. Object-oriented analysis and design are probably not as natural as one would think. So the things that were there at the ideas, like for example, that you just write down a text about the case and then you underline certain words and this is more or less your design. This is obviously quite naive.
Yeah.
And also, as we mentioned, reuse is not as easy. But the main problem coming from the general IT perspective is that the object-oriented technology is not really doing, cannot be used throughout the company because the mainframe is not object-oriented. The database is often a relational database, and also batch applications, for example, that run on the mainframe are not covered at all.
So you say that the OO model was only useful for this relatively unimportant part compared to the rest of graphical user interfaces, and the real stuff wasn't migrated or wasn't touched.
Exactly. And so what the people came up with is that the problems that arise is that logic is done redundant in the client front end and in the mainframe as well. And there is also no clear concept of foreign migration. So if you just say, okay, we are going to take all the logic from the mainframe to the front end, this usually didn't happen. And also in terms of reliability and throughput and so on, it's just something that you can't do with technologies like C++ and Windows by that time. So we are talking about the 90s here.
Yeah, there were several mainframe migration projects where the goal was to switch off the mainframe and do everything on classes of PCs with client server, but I know several projects that failed.
Yeah, actually what you are talking about is sort of the next step. So instead of having just normal PCs on every desk, you do what you need is some kind of modernized server infrastructure, and this is where this clustering comes in and where you have to use clusters of servers. But this is more related to component software engineering. So you are separating the system into several components, and you're using technologies such as CORBA, COM, DCOM, or COM+ from the Microsoft side, or the famous J2E on the Java side, to have an environment in which you can have sort of enterprise objects that are more reliable, more scalable, and are therefore more close to what the mainframe can actually do.
Mm-hmm.
Yeah, and the reason for that was, of course, easier reuse, to separate technical concerns from the business logic, and I think again it was related to a technology shift. So instead of having graphical user interfaces, now web interfaces came up, and this is a new thing that you have to think about.
But what's the relationship between web interfaces and component-based software without the mainframe, except that they happened at the same time, but there wasn't any causal connection, was there?
One of the reasons that were stated for using component-oriented software is that you have to centralize your business logic on a server to reuse it from what we call now rich clients and web interfaces as well.
Okay, so you're saying since the business logic was on the centralized machines anyway, you could easily have very thin clients, and that would be the web clients.
Yeah, or rather the other way around, because you want to have access to the business logic from web clients as well as from rich clients. You need to centralize the business logic so that it's not done redundant in all of the applications.
Okay.
And that's the reason for using component technology.
Okay.
There are those, and of course, the goal was to do everything in a component-oriented system. So you have one centralized component-oriented system that runs on a large cluster. The mainframe becomes nothing more but a data store, and this centralized business logic is used throughout the whole company. So this is sort of what the vendors of such component-oriented systems mentioned as their ultimate goal in terms of IT infrastructure.
And you're saying this didn't happen, or that wasn't a good idea, or because we still go on, we're not yet at SOA, so there's something that has to change.
Yeah, and I mean, quite obvious if you look at how the projects were done by that time. So, for example, in our case, there is a new fulfillment system done in our company, and this fulfillment system is of course done in a component-oriented manner, and it has interfaces to the call center and to the order system on the mainframe, and is sitting somewhere in the IT infrastructure. And now you can use this this fulfillment system from the website and from the call center, so that works. But there is no clear strategy to get rid of the business logic that is on the mainframe. I mean, there could be a strategy that would be to take all the logic and put it on the component-oriented system, but that usually didn't work, as you already mentioned, because it's a lot of business logic. It's a huge risk because you're changing the system that the business really relies on, and it's also something that has a rather vague return on investment, because you invest a lot of money to get rid of the mainframe system, but the return on what you get back is better maintainability, probably, if you do it right, which is something that will just give you a return over several years, because it's easier to develop new software, and this is just a productivity enhancement, and it's not something that has business value in itself. It just makes it easier to generate new business value. And therefore what you end up with is a larger mess than you had before, because you now have the mainframe with some parts of the business logic. You have a separate component-oriented system with other parts of the business logic, and the front ends talk probably to both of those systems, and you end up with more systems, and there is no clear strategy, or there is no way of getting rid of the mainframe. Still what you get is better reuse, because you can have the same front end for web and rich client applications, as we mentioned.
You mean you have the same back end for web and rich client applications?
Exactly.
Yeah, you said front end.
Front end, okay. And there were patterns and practices established for developing such component-oriented systems. So we know how to do them with those rather procedural interfaces and object orientation internally. So that's something that we learned there. So what it comes down to is that there is still the mainframe as sort of an alien part of the IT infrastructure. because you say this is something that we want to get rid of, and there is a strategy to get rid of it, but the strategy is not really useful because it just doesn't pay off.
Okay.
Okay, and
so the next step would be
to take a look rather at the IT infrastructure instead of doing new applications. So what you
the larger picture, basically.
Yeah. So what you usually see in those companies is that there is a lot of several applications. In our case, it's just a component system and some mainframe system that you did yourself. Usually there is also SAP or other ERP applications involved. There is some CRM system and things like that. And all of those applications somehow work together, and there is a large infrastructure in place for the communication between those applications. And this usually leads to heterogeneous environments, to redundant data that is somewhere stored in those systems, and usually this is a big problem. So the centralized application server that component-oriented systems were talking about by that time is just unrealistic, and we'd rather have to look in the integration domain.
So instead of trying to change everything and run everything in one infrastructure, we're now changing our focus to how can we integrate those various infrastructures so that they form a consistent whole.
Yeah, and this is the buzzword for this is obviously enterprise application integration. And the idea is to have one centralized integration infrastructure instead of having every application to talk with every other application. And the reason for that is a rather technical one. So instead of dealing with all those integrations, everybody talks to everybody else, you can just talk to one centralized bus.
So that's where the enterprise, what is it called? Enterprise bus or integration bus or whatever comes in?
Yeah, exactly. And in our company, this has been done. So they did a centralized bus of some kind and integrated the call center application, the fulfillment application, and all these other applications that were around, like CRM systems, ERP systems, and so on. And what they learned is that it's rather focused on data and transformation. And on the good side, there are prepared adapters for several different systems, ERM systems, CRM systems, and so on. And of course, the big issue is it's a distributed system, so you have to think about performance because the network is in there, and this can probably lead to some problems in this field because of network latency and network throughput.
So one thing that might be worth mentioning is also that this was also the phase, I guess, when there was a change of focus from typically like remote procedure call oriented applications as in client server systems over to message oriented systems where asynchronous communication based on well-defined data structures was kind of invented or done.
Yeah, in a certain way, I think message-oriented systems have been around for quite some time.
It wasn't invented there. Like airplane reservation systems and stuff have always been asynchronous and message-oriented, but in this enterprise consolidation area, that's I think where message-oriented became more important.
Yeah, rather fashionable, I would think, because if you think about distributed systems in general, I still believe that most of that a rather large part is done with MQ series, which is now called WebSphere MQ, and this is clearly a message-oriented system. It has been around for ages, so to a certain, it's rather about what becomes fashionable and what people talk about now, and of course you're right in this field. In terms of the IT strategy of the company as a whole, something else is now important. The mainframe becomes a partner. It's not something where you would say, okay, this has to go in a certain time frame, or it's kind of old technology and we don't really want to use it anymore. So it's really taking this into account and not saying we have to migrate away from it. And it's also the first time that there is a strategy in place that takes the whole company into the picture. So it's not saying, okay, we have to somehow migrate this application, but it's rather about the whole IT infrastructure.
Okay.
But still, I mean, talking about enterprise application integration, there is those projects were also quite big. There are several problems. So, for example, where do you set the priorities? Because you can't really have the integration system integrate all of the systems at once. What sense is there in a partial integration? And also, even though technically there is one bus in place now, every application can still talk to every other application. This is
logically, content-wise.
Yeah, exactly. So it's becoming even more easy to have a big mess in terms of who talks to who. And this is now about dependencies, and we had an episode about this. So dependencies in terms of the whole IT system. And it could become even less structured this way. So there is some structuring missing here. It's a rather technical approach, and it's not really talking about the business logic and how business logic should talk to each other.
So this is now, I think, the point where we transition to SOA, right?
Yeah, exactly.
Okay.
So
everything's going to be better with SOA.
Probably.
Yeah, okay.
If you think about what we've been talking about so far, we've been talking about this order process. And actually talking about the order process, it's quite obvious that it's really a business process. So what you should rather think about is what this business process contains. So you could say, okay, there is the CRM, and you have to somehow say, okay, this customer has called and has placed an order. You probably have an inventory system, and you have to take a look at the inventory for the article that is ordered. And you have a billing system, and you have to do the invoice in the billing system and things like that. So if you think about the business process as a whole, you would rather think about several steps that have some business meaning, like note that there was a contact to this customer, do the billing and things like that. And
so are you saying that the first shift in mindset for SOA is actually thinking about business processes and not about different IT systems in isolation?
Actually, I think this is the main step of SOA. So instead of saying there are those systems and they talk to each other, it's rather about there is a business process and the IT has to somehow execute this business process or support the execution of the business process, because parts, of course, are done not automatically, but rather by some human beings out there doing some stuff. And the interesting part is that this view of the business process itself is somehow lost, because what you're talking about in the IT structure is there are several systems, and those systems talk to each other about data and things like that, and there is no place where the business process comes in. And you can, if you think about that, so we were talking about an order process. If somebody calls in and he wants to know the actual state of the order he has placed back then, it's still that there are some services, some systems talking to each other to get the order status. So you have the call center application, some fulfillment and so on, but it's probably different systems and different parts of those systems that are used. This is not apparent in the overall IT infrastructure. You can't see, you are just talking about applications and how applications talk to each other. You're not talking about how the business processes are executed and which systems take part in which business process.
So you're saying, just to recap, the important point about SOA is not that you should define services that are reusable and stuff, but rather that you should focus on thinking about the business process, model it explicitly, and then as a consequence, make the building blocks of those processes reusable in the form of services, because so you can use the steps in various processes.
And also that you have this notion of a business process in place somewhere in the IT infrastructure, because at the end of the day, IT is just about executing business processes, at least the IT that we usually face, which is business IT.
Yeah.
And it's quite, in a way, it's quite funny that even though this is like the real meaning of IT, it's something that is just not there in the IT systems. It's not somewhere explicitly modeled. It's not something that is really used in those IT structures. And this is, I think, the thing that SOA wants to change.
Okay.
Yeah, so business processes are distributed among those applications. And in each business process, just part of this application is used. So what you already mentioned in a way is that instead of talking about applications, you have to have a different thing that the IT consists of, because it doesn't make sense to talk about applications if you want to talk about business processes, because it's not applications that take place that take part in the business process, but rather parts of those applications.
But didn't we have those parts of applications already? We called them components in one of those previous incarnations of enterprise IT.
In a way, this is true, because if you do component-oriented systems, you usually have some services that you export, but this is just true for component-oriented systems. If you think about a mainframe system that has some kind of batch interface and a files are transferred to the system, it's not that apparent anymore.
Although it has been common practice to build componentized or service-oriented adapters on top of the mainframe interfaces.
Yeah.
So in some way you're saying component-based architectures plus explicit business process representation and modeling, that's basically what SOA is all about.
The key point is that there is sort of there is a reason for using component-oriented systems now, and there is a general, like the great meaning of life for component-oriented systems, or rather for services at all in the IT, and this is this business process view. That's sort of the thing. It's not really a technology. It's rather how you think about IT in general and how you want to have this IT done. And if you do component-oriented systems, it's a technical thing that you have to have, and a certain way of implementing things. And with SOA, you can now say, okay, I'm doing this because I want to have this fine-grained services that are more fine-grained than the applications that we are talking about. And I want to have this because I want to execute business processes, and those business processes contain of services. So you're not really doing something different in terms if you implement a new system, but you are rather thinking differently about the IT infrastructure as a whole. So instead, for example, instead of saying, okay, I'm going to migrate away from the mainframe, you would rather say, I will divide this mainframe into several services, and I will integrate those services into my business processes. And if there is some business service that needs to be changed in a way, I will have this business service replaced or done something with it. And this is different from what you would do with component-oriented systems, because there the strategy was just to say, sooner or later we are going to get rid of the mainframe system, and somehow we have to do that, probably in a large project. And here you say, we are going to integrate this, we are going to have services, and then we'll see what to do with those services. Okay, and the other reason for doing this is if you change a business process in the company, you would usually come up with a new system somewhere and put that in place. So, for example, if you say for the order system, you now have to have a bonus program so you can earn points and get rewarded, or have a sort of customer ranking that says this customer is more important to us because we make more revenue with this customer and things like that. You would usually end up with putting a new system somewhere in place that is responsible for this business logic, and you would somehow change all the other applications. While thinking about it the SOA way, you would say we probably need a new service, we need to change the business process as a whole, and we need to have new services integrated into this. And it can then become more logical where you put this new functionality in place and how you integrate these things. So it's just I think the main thing is that you're thinking differently about IT and how to deal with IT, while on the technology side, it's more or less the same that we've been doing so far. So,
but don't we have to use web services for everything?
Not at all, because
I had to add that.
Yeah, because I think the relationship between web services and SOA is that web services are sort of one technology that you could use to integrate several different systems, and they are fashionable. That's one thing, and they are sort of easy to develop, even though this is arguably
sort of.
Yeah, and also I think one advantage is that it's more broadly usable. So, for example, doing call by in Perl is probably not the thing that you want to do, while doing a web service call with some XML stuff in Perl is not that hard. You can actually do that. So this is sort of the thing.
An integration middleware, basically.
Yeah.
And so yeah.
And
right.
It's good for some parts and not so good for other.
Yeah. So what are the main steps that I have to take to get to an SOA, to service-oriented architecture?
So what you need to do is you need to sort of refactor your existing applications so that they become a set of services. You need to integrate those services as parts of business processes to business processes. And this is where technologies such as Beeple come in to execute business processes. You need to generally...
Beeple is the business process execution language, right? It's a formal description for business processes and their steps and orchestration for them.
In the web service technology stack.
Right.
Exactly. And you need to focus on business processes and then integrate those business processes and make business processes part of the architecture. And I think we're going to talk about this in the following episodes.
Right.
And what you gain then is that you can, for example, easily export those services to other companies by having some kind of distributed system across borders of enterprises. And you could also integrate portal servers to have like generalized graphical user interfaces to your SOA. This is generally what SOA is about. And of course, SOA it's service-oriented architecture. So it's an architecture, not a technology, as we mentioned. And talking about architectures, you have to think about, in my opinion, an architecture is about which parts you have to use to build up a software system. In the SOA, this is quite obvious. It's services. And the leitmotif for that is to have business processes in the IT implemented with services. That's kind of the idea. And therefore, you cannot easily just buy an SOA. You have to somehow install it in your IT, and it's a means of restructuring the IT of a company.
Right. That's really important because many of the ESB vendors and of the middleware vendors are trying to make you believe that you can basically you buy some web service, a web services bus or some enterprise integration bus, and that makes you a service-oriented architecture. So that's probably nonsense.
Yeah, and while you can still say that there needs to be a technical foundation for an SOA, and one technical foundation that you can use is, for example, an enterprise application integration system or some kind of message bus. The idea is that, but the enterprise application integration system is rather technical oriented and data oriented. So SOA puts sort of a meaning to enterprise application integration. And as we already mentioned, also object orientation and components come into place with SOA, because component-oriented systems are sort of a way of implementing those services that we've been talking about.
That's something we're going to talk about in the next SOA episode more extensively.
And I think you're saying that rather model-driven software development is the way to implement those systems, but we'll see about
probably.
that. And also object orientation is still reasonably in those infrastructures, because you can use object orientation as a means for doing the analysis, and you can also use object orientation to implement those services. So, and this is quite nice. So with a enterprise application integration, components, and object orientation, the basic technologies are in place and we know how to deal with those. So the new thing is just thinking about IT structure in terms of, or about IT architecture in a different way. So it's not risky in terms of the technologies that we are using. As we already mentioned, for example, MQ Series has been around for ages. It's rather about how to structure the IT, and this is not so risky.
So, but one thing I think is really worth mentioning, and that is that, as you say, it's basically what you need to do is to restructure the IT landscape of your whole enterprise, at least in the end goal, and that means that you have a lot of organizational challenges to face, right?
Exactly, and it means that it's actually something that needs to be done in terms of the whole IT infrastructure. It's not something where you could say we are doing this with this system only. It's the full benefit is only achieved if you do it on the scale of the whole system.
So migrating to an SOA is basically a strategic project, so it's big, and that makes it highly likely to fail.
Yeah, well, but what you're saying is you can't do any large projects at all, and
some people actually really say that, yes. But no, honestly, I mean, the point is, what I think is really a challenge in SOA, and what I experienced in several attempts, let's put it this way, is how to implement the transition to SOA in a way that doesn't require the whole enterprise to change their mind, or the whole middleware infrastructure to be changed at one time, to come up with a step-by-step process, and also see benefits of that step-by-step process in rather early phases than only after 3 years when everything is done. I think that's really a challenge, setting up such a transition pragmatically.
Yeah, you're talking about several different issues here. So one of the technical side, I mean, it's still challenging, but the question is whether you really need to have one infrastructure in place, and because you could also have multiple infrastructures that somehow integrate to have this conceptual bus. So you could say, okay, one part is done with some message-oriented system for those mainframes, and there is another part that is done with JMS for the Java systems, and those somehow integrate and things like that. And the other thing that you've been talking about is that you actually need to change the mind of the whole IT, and this is completely true. I mean, that's what we are talking about, a general shift, and therefore you need to change the whole idea about how IT is done. And this is a big challenge, of course. Yeah. But this is a big challenge in terms of organizational stuff.
Absolutely.
And I mean, if you want to change how IT works in your company, it's quite an issue anyway. So
yeah,
if you have an SOA architecture in place, it's usually associated with flexibility. So you can easily change your business processes now. And actually, I think this is only part of the truth, because what you can do now, if you have those services in place, you can say there are certain services that needs to be flexible. So I keep them in-house. I develop them in-house because then I can easily change those services and can have my special requirements done in those services. And I could also change the business process in my SOA architecture more easily. So that's one thing that you can gain, flexibility for certain services if you want them to be flexible. There are other services that you don't need to be so flexible. And in those services, you can use economy of scale. So you could say, okay, this is something that everybody more or less does in the same way. And you can then either choose to have this service offered to other companies or have your own implementation replaced by services that are offered by other companies.
So what you're saying is, because you modularize your application business logic into well-defined services, you can decide for each of them whether you want to go to do it yourself because it's mission critical and you know it's a unique selling point kind of thing, or whether you want to, you know, like bookkeeping, something you just outsource and use some standard process.
Yeah.
Or some standard service.
Or standard software. And
right.
The interest, I mean, this sounds like far out future stuff, but actually this is already happening. So for example, in Germany, there is one bank that is doing the transfers between accounts for most of the larger banks. And this is actually exactly what I'm talking about. This bank can use economy of scale, so they can offer it more cheaply than the individual banks can actually do it, because they have a larger volume. And the other banks say, okay, this is not something that we want to be flexible about, because it's like normal stuff and
bread and butter stuff.
Yeah, exactly. And for that reason, it's already in place. The other thing that you can do is you can have rather economy of scope. So you can say, I'm going to have a better quality in this specific scope. I'm going to be more specialized in this one sector that I'm talking about. And you are doing the same thing, then you can either choose to export your service and say everybody else might use it because I'm doing it in the best way, or you could integrate services of other vendors. One example that is quite common is customer rating. So companies that make a living out of offering ratings for customers because they know how their financial status is, or they know where the customer lives, and therefore they have an estimate about how much money the customer has and things like that. So this is so what you end up with is that you separate your IT into those services, and then you can think about those services and say, okay, if those are things that we want to be flexible about because it's our unique selling proposition, we're going to keep it in-house and have it more easily changed. If you want to have less costs or a better quality, you can outsource it to some other people because of economy of scope or economy of scale, and you could replace it with standard software. And what you end up with is a marketplace of services that, and each company uses a part of those services, some of them in-house, some of them somewhere else. And as I mentioned, I think this is already taking place. The business demands are there. We had two examples that are quite common already. And therefore, SOA is probably inevitable. It's something that has to take place because those things are already happening.
Of course, being cynic and skeptic, one could always say that back then in the component days, people talked about component marketplaces that people could buy, or they actually could buy the components and run them in their own computing centers. So the difference now is you don't buy the components and run it yourself. You actually just kind of connect to a service that somebody else provides and reuse that one.
Yeah, and also it's important to point out that I'm not talking about the UDDI stuff here. UDDI is this universal discovery directory and discovery interface infrastructure. I don't know. And this should be a registry that is worldwide, and everybody can somehow offer services and other people can use those services. And this didn't really take off, and I believe the reason for that is because it's too anonymous. So what I'm talking about here is that probably even on the level of the executive board, one company talks to another and says, I'm going to outsource my whatever to you, and then this has to be somehow done in IT, and this is not something about automatic discovery of services and things like that. It's rather about a strategic issue of the whole company. And for that reason, it's different from the UDDI approach that was in place originally with web services and so on.
Right. Okay, that's it, isn't it?
Yeah, so thanks a lot for listening.
And the subsequent episodes in SOA will, as we mentioned already, take a look at some more technical issues, like, for example, some new technologies that come up. We'll also take a look at web services and some of the standards there. We'll take a look at model-driven development and SOA, how they fit together. And finally, we'll have another episode which looks a bit more skeptical on SOA and talks about the challenges organizationally and also in actually implementing an SOA in a large enterprise.
Yeah, so if this was too high level and too far out for you, then you could listen to those episodes, and of course we would be happy about any feedback that you would give us.
Okay, so before we close this session, I want to mention that Wiley has reopened the special offer for getting the book on model-driven software development. You might remember we had this promo code called FAD, and they have reopened it until the end of October, I think. So if you're interested in getting the model-driven software development book we talked about in previous episodes, you can go to the Wiley website and get the book, I think, 20% off the regular price. Okay, so thanks for listening. See you next time. Bye. Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.